Live from the Icebox Studio in Montgomeryville, Pennsylvania. It's the Bill and Corey Show. I'm Bill.
And I'm Corey.
Hey, welcome back to another episode of the Bill and Corey Show. We had some good questions today, and we're going to do something new today. We're going to have two cameras in the studio, so hopefully we can do some close-ups here.
Sounds like twice the fun.
It could be twice. It could be very funny. So we'll see how it goes. And also, we have our YouTube chat set up. So that's, if you have any questions, just type them in there, and we'll hopefully get to them. First question is for Corey. This is on a purifier question. It says, we recently purchased an inline purifier, part number SEQ PUR-IL-OMT1, it's quite a mouthful, which I'm about to install. We are planning to use this product with a carbon monoxide cylinder, but I like to fill the purifier with helium first to check for leaks. We can do this without disconnecting the purifier, but we'd like to have the flow helium in reverse, direction of the normal flow. Would this be okay to do? And briefly sure there are not leaks. We want to check sure there's no leaks before we start flowing carbon monoxide gas in there.
So as you can see, I'm holding here is one of our purifiers, and to answer the quick question from the caller or from the emailer, yes, you can put reverse flow in here, and it's not going to hurt anything. You can pull a vacuum on it. This is one of our many. As you can see, it's an indicating. As you can see, it's clear because you can see the beads inside, as Bill likes to call them, the magic beads. Yeah. They will change color when they get saturated. I do not remember what they are, but they're actually indicated on here, the colors. If you can zoom in, there are actually oxygen will go from green to yellow when it's moisturized, or clear when it's saturated, and moisture will be yellow, then it go clear to saturated. So it tells you what happened on there. We also have a indicating hydrocarbon as well can be added in there, or the indicating ones can take out less of the contaminants. So So if you want to have a more robust one that takes out more contaminants, non-indicating ones will last longer. So yeah, so we have a whole line of these inline purifiers, or one with a base as well.
Yeah. And that handles 160 psi purity, it'll do 25 liters a minute max flow rate, and it'll take out water and oxygen. So, yep, okay, thank you. And next question's for me. Says, can I get a quote for a CJ670 gas regulator? Also, if possible, could you please explain to me what is the difference between the delivery pressures? Thank you. This is the 3610A 670, 100 psi, and the 3613A 670 at 30 psi. So, what's the difference between the two? Well, you can easily say it's 70 psi, but no, it's...
I was just going to say, you just got to do the math, right?
Yeah. No, but seriously, this is a 670 it's a corrosive gas, and you can tell by the notch on the nut that it is left-handed. Now, this is really kind of like how low can you go with delivery pressure range?
Yes.
Now, this is a stainless steel diaphragm, so it's 100 psi maximum working pressure, delivery pressure. So you could take it down to about 20 psi-ish. So that's kind of a good rule of thumb, is to go, you can really control it down about 20%, because it has to do really with the spring, the spring that's in there, and how well you can adjust, how tightly you can adjust that, and such. And
combined with the outlet gauge and how easy.
Yeah, the outlet gauge too is it's gonna be harder to read at the lower end and not as accurate. And there's other things, such as when you have droop on the regulator, when you get a higher flow condition, it might be harder to control at the lower end. Now, if you had this regular stainless steel diaphragm, if you had one of our economy industrial grade type regulators that has a rubber type diaphragm, you could probably take it from 100 down to about 10 psi, because the rubber's a little more responsive. So that's where you go on this regulator. Next question will be for Corey. This is a rotometer question. We have an auto welding machine with a Matheson flow meter with the part number SEQ J13A201J555 integrated on it. I was hoping to get some insight on desired input pressure for the flow meter. I couldn't find this part number on your website. We are using argon gas. Okay, there we go.
All right. So this is the J55 tube, actually. This little guy right there. It has a valve on the inlet based on the part number, and it's for 10 to 90 standard cubic feet per hour of argon. And it should work with 20 to 50 psi-GN. Now, the reason why you couldn't find this one is because we can't possibly list all of the variations. There's probably, thousands of variations of these tubes that we can do different things. So that's why it's not on our website. We just put the most popular ones on there, the ones that get used the most. And so if you have any questions or have any exotic type rotometer questions, please contact one of our salesmen. They'll be happy to help you out.
Yeah. Now, I'd like to add something too on this. This is a direct reading scale. I said it's 10 to 90 standard cubic feet an hour for argon. A lot of our rotometers, this is FM 1000, a lot of them are calibrated in air, but we can do, obviously we do this one for argon and this. So yeah, we don't list that because we have a lot ones to list.
Yes.
But so that's that.
And reference scales are much more, they can be versatile. That's the word I'm looking for. They're much more versatile. So that's why we use those more.
Okay, here's a good question on regulators. I've been using a Matheson regulator for a bit now on my schlenk line.
Schlenk lines? Everybody knows that, right?
No,
invented by Wilhelm Schlenk. He was a chemist in Germany. It was around the 1920s. It's a vacuum gas manifold that uses a cold trap to keep contaminants from the gas bubbler getting into the line. It's a pretty interesting device. Still used today. I mean, 100 years later.
100 years later.
Amazing. Amazing.
Yeah. Don't ask me how to use one of them.
No. Just pull some levers, turn some knobs.
They noticed the sound of gas leaking from a hole on the side of the regulator when high pressure is being applied. I'm wondering if this is normal, like a feature of the regulator, or if this is supposed to be something screwed into the hole to prevent leaking. Please let me know. Okay, well there's a bunch of different things on here. Now, this is just the regulator body, and I got this one because I can take it apart. It's just one of the ones we have laying around. What could be happening with your regulator is something called harmonics at certain flow conditions. The diaphragm will vibrate back and forth and might sound like a hissing sound. So we've had customers complain about that and think that it's leaking, and it's not really leaking. It's when someone says it sounds like it leaking, it could be harmonics. And a way to check is to check to see if you actually have gas coming out of the bonnet vent hole. Now this is a two-stage regulator, and with this regulator, that's the bonnet vent hole. This one is threaded. It's an 1/8" pipe thread. If it's a hazardous gas, you can pipe it away.
Or flammable if you want to as well.
Yes, and flammable. Anything hazardous, you want to pipe it away, you can do that. Now, gas leaking out there is not normal, but if you have something you think it might be leaking out there, you hear it, not sure if it's harmonics, you could take different things. You could try to put like a soap film over there to see if it's going to bubble or not, or you could take a plastic tube and then run the tube into a glass of water to see if gas is leaking out through there. Cool. So gas leaking through there this is a safety device. It should never be plugged. And what could happen is this is the bonnet which holds the spring. I'm going to take it apart and show you.
Ooh.
That's why I have this regulator, not a full regulator. There you go. So this is the diaphragm that goes on in the regulator, and you could get a leak pass there either in the seal, or you could possibly have a hole in the diaphragm. It's
very thin metal.
It's thin metal, but it's unlikely that would happen. And corrosive surface, it's a higher chance of happening because you could get some corrosive gas puddling in there and you get a little hole through there. Could just be that it's leaking past the seal you have there. And the bonnet itself, that holds, you really can't see it because there's all sorts of little spring thingies on there. But there it is. There's a little spring in there, and there's the adjustment knobs that tightens the tension on the spring. And the bonnet isn't rated to hold full cylinder pressure. That's why you have a bonnet vent hole on there. So if there's a leak in there, it'll come out and not blow up the bonnet. So,
yeah, because nobody wants that's just it's a bad time.
No, you really don't want it. You really don't want to have that happening. So that's all the questions we have for this week. Thanks for joining us, and please subscribe to our YouTube channel. And if you subscribe and hit that little notification bell, you'll get notified of the Bill and Corey show. You get a personal invite to it.
Oh, that is.
And you also get notified of any new videos that are coming out. So.
And it's not just Bill and Corey show videos, right? Or is it just Bill and Corey show?
No, I'm sorry. They have other technical support videos in there. It'll tell you all sorts of different things. So once again, thanks for joining us, and see you next week.
Set your VCRs for next week at Thursday, 10 a.m.